Hello everyone. In this video, we are going to solve question number 27 of GATE 2010 paper. So the question is on differential equation. The question is the solution of the differential equation for y of t is equal to, your differential equation is given as d2y upon dt square minus y is equal to 2 cos of hyperbolic t. Initial conditions are y at t is equal to 0 and dy by dt at t is equal to 0 is 0. So in order to solve this question, this is a second order linear differential equation, and it is inhomogeneous because the right hand side of this equation is not, this side is non-zero. If it was 0, it would have been a homogeneous linear differential equation. So in order to solve this question, we need to find two things: complementary function and particular integral. So let us take in order to find the complementary function, let us general solution. This is a general solution, how we write of it consists of two parts: finding complementary function of the general solution and then particular integral of the general solution. To find out the complementary function of the general solution, you just take the LHS d2y by dt square minus y is equal to 0. Let y is equal to e to the power rt. Therefore dy by dt is, this is a solution which you have to suppose. And d2y by dt square will be r square exponential rt. I put this in this, and you will get r square exponential rt minus exponential rt is equal to 0. You can take exponential rt common, so r square minus 1 is equal to 0. Now by definition, exponential rt is equal to 1 plus rt whole square upon 2 factorial and so on. Is it not equal to 0 here? So by definition of exponential rt, it is not equal to 0 because it can be at least 1, greater than equal to 1. Therefore you have to just solve it. Give me 1 minute. So exponential rt cannot be equal to 0. Therefore r square min is equal to 0. Therefore r square is equal to 1, which gives r is equal to plus minus 1. Therefore your complementary function will be of this form: a e to the power r1t, that is 1t, plus b e to the power r2t, that is minus 1t. There are two roots, say r1 is equal to 1 and r2 is equal to minus 1. So this is how you write the complementary function general solution. Complementary function general solution is just some constant times exponential r1t plus some constant exponential times r2t. So here our r1 is 1 and r2 is minus 1. Therefore this is complementary function solution. Now to find the particular integral, you will just write you can write this equation as d square minus 1y, where d is nothing but d upon dt. You can write this. So you can write this. Therefore you can just, in order to find the complementary function, you just write dt square minus 1 times your RHS. Your RHS is 2 cos hyperbolic t, where, as already discussed, d is nothing but a differential operator, d by dt. Okay, now you cannot operate this. So what you will do, you will differentiate this differential operator, and first of all you can just, by property of exponential t, you can write this as et plus e to the power minus t upon 2. So 2 to cancel. Now it will become 1 upon d square minus 1 e to the power t plus e to the power minus t. Now in order to solve this, what you will do is that you will just differentiate this. So differentiating this will become 2d minus, only 2d will come, and take one t common outside. and write everything as it is. This is just a way to solve. And now you know that d is nothing but d by dt. D is nothing but d by dt. Therefore 1 by d is just the integral of this. 1 by d is just the integral of this function, and we'll integrate this function, we'll get e to the power t minus e to the power minus t, and this is nothing but t sine hyperbolic t. So particular integral is this. Therefore your solution is y is equal to a exponential t plus b exponential minus t plus t sine hyperbolic t. This is a solution. Now you will use initial conditions, that is at y t is equal to 0 is equal to 0. So just put t is equal to 0 everywhere in this way. A plus b plus, so a plus b plus 0 is equal to 0. This will give a is equal to minus b. Now find dy by dt, because dy by dt at t is equal to 0 is also 0. So exponential at minus exponential t minus b exponential minus t. When you solve this, it will become plus t cos hyperbolic t minus a plus t. Now you put t is equal to 0 here, so you will get a minus b plus 0 is equal to 0. Therefore a is equal to b. So you got two functions. So you just solve these two, equation a and equation b, and when you solve this equation a and b, so a minus b is equal to 0, a plus b is equal to 0. So here 2a is equal to 0. So both a and b will come out to be equal to 0. Therefore the solution will be y of t. Since a is 0, b is 0, so you are left with only t sine hyperbolic t. So this is the answer for this question, which is D option. D is the right option. So you have to first find the complementary function by equating the left hand side of the function left hand side of the equation equal to 0, and then you have to find the particular integral in this way. And this is how you solve this question. Thank you for watching this video.